So we're going to learn how to determine what the shape of a molecule is, and whether you're on virtual when you guys go home and you want to see this again, it'll be on PDF and there'll be a video, hopefully, of me showing you how to do this. We are always going to consider which atom is in the middle, and we're going to look for the one that has a subscript of 1. Now, it says here, in the formula, it usually is the first symbol. Usually. Is that the same as always? No. So it's frequently true, but it does not have to be the first element, okay? All right. In the formula, it's usually the first symbol, but it always has a subscript of 1. That's going to be the key thing we look for, okay? Now let me introduce you to the middle atom a little bit here. So here, carbon is in the middle. Okay, here, this would be the oxygen that's in the middle. Here, it'd be the boron that's in the middle. Is it easy to identify the middle atom? You see which atom's in the middle. So it's really not a complex term. Okay, moving on. Then we're going to have to consider how many bonds does this element need to make. Now, in order to determine how many bonds it needs to make, we are going to look at its Lewis dot diagram. Remember I practiced with you Lewis dot diagrams last class? Well, here we go again. The Lewis dot diagrams, and I put them on the front page of the notes so that you could look up the Lewis dot diagram in case you don't remember or didn't really learn it that well. You can look up what it looks like, and after you've looked them up a lot, you probably will start to learn how to do it even if you really didn't learn it at all yet. And if you're still working on assignments from the first grading period and you're trying to get credit for this one, I'm helping you right now with making up credits. Okay, so I will use this chart to help you also see how answers occur in a PDF on Schoology with these notes. I've used this tremendously to explain answers. All right, so first, we need an example so we can practice these steps. On your notes, it says NBr3. Now, just for a moment, I'm going to write everything I'm thinking on paper, and then I'm going to go back and fill in the worksheet with you, the example problems, okay? So I'm taking a piece of paper so I can write everything down so you don't have to read my mind so much, what I'm imagining. Okay, NBr3. I bet you have no clue what compound that is, other than we could call it nitrogen tribromide. That's all we probably can say about it as a brand new student to this. All right, let's learn. Which of these elements is in the middle? Is it the nitrogen or is it the bromine?
The nitrogen.
Yes. Why did you pick nitrogen?
Is it because it got 1 subscript?
There you go. Nitrogen has a 1 for a subscript, so that means our nitrogen is in the middle. You got it. Nitrogen's in the middle. It has 1 for a subscript. Understood 1. Okay, it's the middle atom. Okay, that's our first task. What's in the middle? Okay, now we're going to consider our nitrogen, and we're going to make how many valence electrons? Let's see. I'm going to look up on my ordinary periodic table. Okay, nitrogen is here.
That's 5.
You said what? 5. Very good. How did she know 5 valence electrons?
Because it's in group 15.
It's in group 15, correct. Because nitrogen is in group 15, we know it has 5 valence electrons. Okay, I'm going to write it all down, but again, I'm going to go back to the paper later, and I'm not going to write quite as much. But now you're seeing group 15 is how we know it had 5 valence electrons. And I'm writing real big, so hopefully it'll show up on camera well. Okay, now that I know that it has 5 valence electrons, I can draw the Lewis dot diagram for it. Okay, I'm going to draw the Lewis dot diagram, because that will help me understand how many bonds it can make. And once you know that, it will determine the size choices that you can make. Okay, Lewis dot diagram N, it has to have 5 valence electrons. 1, 2, 3, 4, 5. 5 valence electrons, okay? All right. Now, I want to know how many bonds, okay? How many bonds will this make? The way you know how many bonds is you look for lonely electrons. So, you got it already, lonely electrons. So, oh, I need a partner. I'm all alone. And I'm being silly on purpose so it'll get your attention. Yes, ma'am, question.
Actually, no, never mind.
Okay, so it has 3 electrons that are lonely. And because there are 3 of them, has 3 lonely electrons, I know it needs 3 bonds. That's it. It needs 3 bonds. Now, this is the first example, and I've already thrown you a little bit of a curveball, although you've not said anything wrong. Please don't even think that. Okay, this has a bond. It's going to be made in a little bit. This will make a bond. This will make a bond. This will make a bond. Oh, look at that. We got a pair of electrons left over. And this is the middle atom once we make our compound.
Oh, I know the answer.
What is that, Armani?
It's tri.
What is, I'm not doing shape just yet. What do we call these electrons that are left
A lone
over?
pair.
Lone pair, that's what I'm trying to say. We'll also have a lone pair, okay? There will be one lone pair after these 3 bonds are made. There will be one lone pair, and right here it is, after these bonds are made, okay? Now, I told you that I would show you how to fill in the paper. I'm going to take this information, and I'm going to put it on the paper with you, and then we'll pick the shape in Armani Hush. Okay. So, I'm taking this aside. Don't worry. I'm putting it down again, but I'm putting it here. Okay, so we said nitrogen is in the middle. Okay, nitrogen's in the middle. We had to know that. And it's because it had a subscript 1. That's how we knew. Okay. Next, we know that it had 5 valence electrons, but you know, I'm just going to go ahead and draw the Lewis dot diagram right here. 1, 2, 3, 4, 5. I have 5 valence electrons on my nitrogen. And because it has 3 lonely electrons, we know it needs 3 bonds. Okay? Lonely electrons each need their own bond, so that's why it's 3 bonds. Then, oh my golly, after they make bonds, we have this pair of electrons left over, and they will be a lone pair of electrons. We have one lone pair of electrons that will occur. Okay. Can I have you look at the formula a quick second? How many bromine
3.
are going to bond to the nitrogen? Yeah, it's 3. Do you see how it needs 3 bonds, 3 bromine? It's a perfect match? Good. So that is good. Okay, we have 3 bromine. That's perfect. Perfect match. All right, so here's what we're going to look for. We are going to look through all the shapes. I'm going to pretend that you don't have any idea. We're going to look through all the shapes, and we're going to see which ones match this picture, okay? I'm going to go back to the previous page, so you will see this again. We'll finish it. Okay, 3 bonds. Okay, now, remember we did say that linear could have a triple bond, couldn't it? All right, so I'll keep hold of this one just for a minute, okay? But do the others have 3 bonds? No. It would have to be this one if it was going to be a linear at all. This is the only one with 3 bonds, right? Okay, I'm going to set that aside. Okay, look at this one, bent. How many bonds?
3.
Okay, let's count. 1, 2. That one has 2 bonds. When you have bent, it has only 2 bonds. 1, 2. 1, 2, 1, 2. Whichever one you look at, it doesn't matter. They all have only 2 bonds. Good? All right. Now let's look at this one. Trigonal planar. How many bonds do you see?
3.
Yes, that one has 3 bonds. Oh, okay, so I better pull that one out. Okay, pull that one out. Here's my trigonal planar. I got it ready. Okay, I'm going to turn the page. Okay, how many bonds here? How many bonds here?
3.
3, yes. 1, 2, 3. So I better pull that one out. Trigonal pyramidal. I've got that one pulled out because it has 3 bonds.
Slide it down, Miss Peterson.
Oh, thank you very much. 3 bonds. Okay, then we need tetrahedral. Okay, tetrahedral. How many bonds does it have?
4.
Yes, it has 4 bonds. Tetra means 4. 4 atoms attached, 4 bonds. I think counting the bonds is probably the best way. 1, 2, 3, 4. Tetra means 4. Is that going to work? No. It has the wrong number of bonds. Okay, so we have these choices. We have this choice, we have this choice, and we have this choice. Let's look at our description again. Now, it says it needs 3 bonds, check. But then it says 1 lone pair. Does this one have a lone pair?
No.
No. And I'll remind you in the picture. No lone pair. It even says no lone electrons. That's no lone pair. This is what a lone pair looks like. Okay? The lone pair kind of looks like that balloon, and I draw it by hand looking like that. Other teachers might not, but I promise to always do it like this whole school year if we need to draw it at all. Okay? I'm going to turn the page. All right, what about, okay, so this one, goodbye, wrong shape, can't work. Okay, now this one, does this one have a lone pair? There's something else wrong with it. See how many atoms are here? 1, 2. How many atoms are in our formula? We have 3 bromine and 1 nitrogen. 3 plus 1 is 4. That's not even the right number of atoms. This is 2 atoms. We need 4 atoms. Oh, goodbye. Forget it. Right? It does not match at all. So we have 1 option left. Let's check it. Okay, so I have 3 attached to the middle atom. So I have 1 nitrogen and 3 bromine. Does it have a lone pair?
Yes.
Yes, we found it. That's it. You see how you just knock off the choices that don't match? So this one, what name was this one? Trigonal pyramidal. Okay, trigonal. 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 And then pyramid. Okay, pyramidal. Pyramidal. There's a gentleman on the internet teaching the shapes. I like his video a lot. He happens to call it trigonal. Who cares? Trigonal. Trigonal, triangular, it's all the same. Okay? All right. Now we're going to try the next one. Okay, we have CBr4. Okay, which element is in the middle?
C.
C. How do you know?
Because it has subscript 1.
Subscript 1. Okay, carbon is in the middle, and I'm going to shorten my description because you already know we're talking about the middle atom. Okay, carbon's in the middle because it had a subscript 1. That's how we knew. Okay, now we're going to look it up on the periodic table. How many valence electrons does carbon have?
4.
4. Because what group is it in? 14. Okay, group 14 has 4 valence electrons. Okay? And remember, these diagrams are on the front page of today's notes. It's inside the PDF notes on the internet, Schoology, so if someone needs it. Okay. We got 4 valence electrons. Okay, that's how it's drawn on the paper. How many lonely electrons are there? They don't have a partner. 4, right? So what do we know that means? It needs
4 bonds.
Needs 4 bonds. There you go. It needs 4 bonds. Carbon being able to make 4 bonds in all kinds of ways. Sometimes they're triple bonds. Sometimes they're double bonds. Sometimes they're single bonds. That is what causes variety in life. Period. It's also what makes organic chemistry a hard class. But okay. Carbon needs 4 bonds. All right. How many bromine are there to attach to carbon? 4. We have 4 bromine to attach. So perfect match, right? Okay, and again, I'm going to be silly. I'm going to pretend I don't know the answer. Let's go back to the beginning and look for 4 bonds. Okay, back to the beginning. Okay, now linear is special. We could have single bond, double bond, triple bond. But even if I did that, oh wait, here's carbon dioxide. It has 4 bonds, right? So I'm going to pull that one out.
So
Because-
that's linear.
Yeah, there's one way of doing linear that makes 4 bonds. So I pulled it out. Okay, it has 2 double bonds. Okay, that's one way of having 4 bonds. Okay, I saved that one. Okay, look at bent. How many bonds? 1, 2. You have to be able to count them, otherwise you won't be able to do this. There are 2 bonds. Does that match our description? No. Goodbye. Bad choice. We're not going to do that. Okay, look at trigonal planar. How many bonds? 3. Nope, that's not 4 bonds. Throw that one away. Nope. Okay, go to this page. How many bonds on trigonal pyramidal? 3. Get rid of that one. See how nice this is? Okay, then look at tetrahedral. How many bonds?
4.
4. That's what tetra means. Okay, so I'll pull that one out. So these are our 2 choices for having 4 bonds. Okay, let's look at our description again. CBr4. It needs 4 bonds. 4 bromine are going to attach to the carbon. When I look at this one, how many things are attached to it? 1, 2. This has only 2 atoms attached to the middle atom, doesn't it? Can this one be CBr4? No, not enough atoms. We'll get rid of that, right? That does not have enough atoms to even make CBr4. And that's how you get rid of choices you don't want. Okay? Also the lone pair, but we don't have any lone pairs here to even talk about. Okay, look at the tetrahedral. All right, so here's my carbon. Now let's see if I can do 4 bromine. 1, 2, 3, 4. That's it, wasn't it? This is the one that's tetrahedral, and it has 4 atoms attached to the middle atom. That's how they get 5 bonded atoms total. Okay, so we found it. It's tetrahedral. Do you like how we keep using the same steps again and again to get our answers? I'm going to try to do that every opportunity I can while teaching you chemistry. Okay, let's look at OS. All right, trick question. Who's in the middle? I have Christopher and I have Rachel right there. Is anybody between them?
No.
No, you can't do it. If you have only 2 people or 2 atoms, can anybody or anything ever be in the middle? No. So, trick question, like I said, no atom in the middle. Or no middle atom would be faster, right, wouldn't it? No middle atom. Forget it. It's not even going to happen. Tell you what, that right there already makes you have only one answer. What is the only structure possible when all you have is 2 atoms?
Linear.
You already found it. It's linear. Isn't that nice? Because you have no middle atom, it can only be linear. And so just to be nice, I'll go ahead and draw it for you, show you how it happens. Okay, oxygen's in group 16. How many valence electrons?
6.
Yes, 6. 1, 2, 3, 4, 5. And I'm going to purposely put the 6th one over here. Okay, now I'm going to do sulfur. Okay, sulfur's in group 16. How many valence electrons?
6.
6 again. 1, 2, 3, 4, 5, and I'm going to put the 6th one here so that the lonely ones are facing each other. It just makes it easier to see. Okay, so when I bond them, this lonely one and this lonely one kind of like hold hands. Okay, they make a bond. And this lonely one and that lonely one make a bond. So you can make a double bond between two different elements. Totally normal. And that's what it would look like. Linear. Okay? All right, let's keep going because there's lots of things we need to practice. Okay, CO2, who's in the middle? Carbon, right, carbon's in the middle. Oh, we had carbon a second ago, so you already know some information about it. How many valence electrons?
4.
4, yes, group 14, 4 valence electrons. 1, 2, 3, 4. Oh, we already know, how many bonds does it need? 4. It needs 4 bonds because that's what carbon always does. Silicon is like carbon. It would need 4 bonds also for discussions in our class. Needs 4 bonds because it had 4 lonely electrons. They need a partner. Okay, now look at the formula. How many elements are going to attach to that middle one? 2. We have 2 oxygen in the formula with it. 2 oxygens are going to attach to the carbon. You see, I got that right off the formula. Now, a little bit ago, you already told me that tetrahedral had 4 bonds, and you told me that linear, like this, okay, 2 double bonds, you told me that had 4 bonds. But what way does it have to be to have 2 oxygen attaching? Will it be linear or will it be tetrahedral?
Linear.
Yeah, it has to be linear. Tetrahedral has 4 things attached, 4 elements attached to the middle one, or 4 atoms attached to the middle one. So it cannot be tetrahedral. It has to be linear. 1 atom in the middle, 2 atoms attached. That's the one. So the answer is linear because of 2 oxygens to attach. It's going to have to be, because of the 2 oxygen, it has to be 2 double bonds. Because 4 bonds to be made to only 2 atoms, it has to be 2 doubles.
So there's 2 bonds and then 2
Right,
lonely ones?
right. We have 2 atoms, and each of them have to take a double bond. Here's a double bond, because that's the only way you're going to get 4 bonds that that carbon needs. Good? 2 double bonds.
Would it be better?
It's linear because there's no lone pair.
Oh,
Okay, better? You have perfect questions, thank you. And let's do number 5. And then I will skip down to number 7. Okay, number 5. H2O. Okay, which one's in the middle?
Oh,
Yes, you did not say hydrogen just because it was first. Hydrogen, there's 2. If you're going to be in the middle, there can only be 1. So it is oxygen that's in the middle. Okay, oxygen's group 16. So how many valence electrons will oxygen have?
6.
6, yes. So I'm going to put O, 1, 2, 3, 4, 5, and I'm going to come over here and put number 6. And I hope I'm drawing these big enough that you can see. Dark enough too. Okay, now count them. How many lonely electrons does oxygen have?
2.
Yes, it has 2. 1, 2. So oxygen needs how many bonds? 2, right. All oxygens need 2 bonds somehow. Oh, look what happened. When you have 2 bonds, these electrons are left over, and these electrons are left over. What do we know those are called? The electrons.
Lone pair.
Lone pairs, thank you. So we have 2 lone pair, don't we? There are 2 lone pair in this structure. 2 lone pairs. Now, Oxygen doesn't always make lone pairs. But we're doing covalent bonding, not so much of the ionic part, so anyway, 2 lone pair. It needs 2 bonds. Now, how many things are we going to attach to this hydrogen? To this oxygen? How many hydrogen are going to attach? 2. Okay, look at that. Needs 2 bonds, and we have 2 hydrogen to attach. That's perfect. So, since I have 2 hydrogen, and I need to make 2 bonds, that means we're going to be singles. It's going to be 2 single bonds. Does that make sense? 2 atoms, I need 2 bonds. There you go, 2 divided by 2, we're going to have single bonds. I don't know if that part made sense, but we have 2 bonds, 2 hydrogens, they're going to be 2 single bonds. So, oh, but look, I have that 2 lone pair. What is the only shape that have 2 lone pairs? You already said it a second ago? Bent, yes. Bent is the only one that has 2 lone pairs in our work. If you were to go farther in chemistry, there are other shapes. We don't care right now. We're not learning those. I did not put any of them in your questions. So this one has 1, 2. There's the 2 hydrogen. Here's the oxygen in the middle. And here's the lone pairs of electrons. So it is bent. Questions? You're doing a good job asking questions as we go, so I think we're okay. All right. Let's go down to number 7. All right, here we go again. Which element's in the middle?
B.
B. Okay, so let's do a skills check. Can everybody identify the middle atom? Now that we've done quite a few, do you feel confident you can identify the middle atom? Okay. Now, how many valence electrons are on boron? Here's boron. 3, right. Group 13, 3 valence electrons. So draw it, and again, you can use the picture that's inside of today's notes on Schoology, on the PDF. It is in color. Here on your paper, it's gray because it's just black and white printing. Okay, so boron has 3, 1, 2, 3. Okay, there's our boron, the way it's prepared for bonding. Now, how many bonds does it need to make?
3.
Yeah, it needs 3 bonds. We have 3 lonely electrons. Boron, according to our work today, needs 3 bonds. But you know, it needed 3 bonds when we did ionic bonding too. Now, just to show you, okay, this one makes a bond, that one makes a bond, that one makes a bond. Are there any electrons left over?
No.
No. So there are going to be no lone pair because there are no electrons left over. If we had electrons left over, I've shown you that I circle them because it makes lone pairs easier to identify and easier to count. Okay, no lone pair here, there's no electrons left over. Okay, 3 bonds, no lone pair. Let's look. Okay, this one had 4 bonds. Forget that one, that's already gone. Oh, this one has 3 bonds, so I can save that for a moment. Okay. Oh, here, this one has 3 bonds, right? I can save that one for a moment. How many bonds are in this one? 2. Does that work? No. Wrong number of bonds. And it could be linear if it had single bonds like that, like with magnesium chloride. Would look like that. So I'll pull that one aside just for a moment. Oh wait, how many bonds is that? 2. Well, forget that. That's not going to work after all. So for 3 bonds to work, we have only these 2 choices. Now, which one is correct? Trigonal pyramidal or trigonal planar?
Planar.
Yes. Trigonal planar is correct because no lone pair. Okay? No lone pair means that it is trigonal planar. Or if you wrote triangular planar, that's fine as well. trigonal planar. Okay, so we've done 6 examples together. There are all the examples available on Schoology if you need it. So I hope you find that helpful.